today is Andy Carrigan, the Central Region Sales Manager for Filtrexx International, and today he'll be covering an overview of sustainable solutions for bank and slope restoration. Andy graduated from Houghton College in Western New York, and throughout his career, he's had roles in leadership and team development, sales, and sales management. He's worked in the construction, material, and installation sales industry for over 18 years with a focus on geosynthetic, erosion, and sediment control material sales and market development. Andy has served on the marketing committee of the St. Louis USGBC, and he's also a member of the Missouri American Public Works Association and the International Erosion Control Association. He's excited about educating the building community on the environmental benefits of living walls and best practices for their use. Be sure to connect with him as well as Filtrexx on LinkedIn. With that, I welcome Andy Carrigan.
I thank you, Kristen, and good morning, everybody. I hope I'm coming through clear and hope everybody is doing well out around the country and wherever you are. So today's topic is sustainable solutions for bank and slope restoration. And we're just going to jump right into it here. And let's see. Let's get it to advance. There we go. So just to give you a quick overview, going to talk about a couple different things with bank and slope restoration, kind of like the issues that you run into when we're dealing with banks and slope problems, solutions, some of the traditional ones and some new ones and things that Filtrexx brings to the table. We're going to talk about sustainability and how sustainability factors into long-term solutions. And along the way, we're going to talk a little bit about Filtrexx and our story, who we are, how we fit into this whole model of sustainability and kind of what our solutions are. And then we're going to talk about projects as we go, the benefits of the systems based on some of those projects, and then the impact. And just to kind of give you a nice broad overview. The goal is not to go real deep into erosion control or sediment control or to be technical about sustainability and what that's all about. I think for the most part, we all are aware of issues in our environment and things that we're dealing with and the importance of sustainable solutions. So with that, let's just jump right into it. So what is the problem here? What are we dealing with? How often have you seen issues? We're going to take a look at a couple different bank and slope challenges that we face, whether you're an owner, whether you're a designer, or whether you're an engineer or a contractor who's tasked with repairing, replacing, restoring these situations. And these challenges that we're facing when it comes to slope and embankments are critical. They're expensive. They cost us money, and they have an impact on our lives and our well-being, as well as we have an impact on the environment around us. And don't know about you. I've done some kayaking before, and I see plenty of times on the river where you see situations like this. So let's look at a couple of them around the country. This is a project. It's in eastern Tennessee. You can see that there's a serious issue here with erosion, cutting into the roadway, cutting into the channel next to the roadway. But this could be anywhere in the country, and these are not uncommon types of situations. Or an embankment along a private residence. There's plenty of people that live in areas with embankments around their house, whether there's lakes or shorelines nearby, or whether there's just a slope, and we see these kind of challenges that need to be dealt with, and we want them to look nice, we want them to stay in place, and we want to take care of our investment, our house or our property or whatever we have behind that. Stream banks and river banks, constantly dealing with erosive forces of water and wind and the impact of that. Again, erosive forces on this particular project. This is out in California. The last one was down in Alabama, Georgia. This on the left here, you have a railway, the California Railway. On the right, you have houses, and you can see that the waterway that is over time has been eroding into these properties. They're about to lose sensing in the next year or two if something is not done. Another project, another situation, again, not uncommon around the country. This one is particularly out in Northern California. What you can't see in this particular project is there's actually a stream bank right there at the bottom. But this kind of displays a little bit what people try to do, what kind of solutions, you know, are put in place to try to hold embankments in place, and they're not necessarily engineered all the time. Sometimes it's just a sheet of plastic to keep the water off of it, or a fence line to hold something in place. Not, again, not an engineered solution, but definitely some kind of effort. And again, kind of going back to roadway situations, here's a good example of a roadway. This one happens to be in Pennsylvania this time, where you can see the erosive forces of over time of this stream bank are eroding into what's the road up top there on the left, and they're starting to lose the guardrail. They're starting to lose the pavement. So we kind of know what the issue is. And we kind of know what's causing it, but let's kind of talk about the root of the problem. Once it's exposed, you know, we have to deal with some of these issues. You know, and really it comes down to the movement of dislodged particles, which really is the definition of erosion. You know, and think about the last couple of slides I just showed and that we went through. What is the common influence that's evident through all those slides? Wind, water, gravity, human influence. You know, and think about how those influences move or impact our soils. Anytime you disturb soil, whether it's the flow of air or wind or gravity, you know, or you lose some vegetation, the cohesion of the soil, the ability of the soil to stick together is minimized. And so you end up with soil loss. And so that kind of is what's the heart of the problem, the challenge that we're facing. What are some of the solutions traditionally that are in your toolbox? We all, as a designer, as a developer, as a contractor, we have some tools in our toolbox to solve these kind of problems. And traditionally, we see things like riprap. We see concrete revetment, concrete systems. There's all kinds of rolled erosion control products, blankets, TRMs. There are cellular confinement systems. There's gabions, rock gabions, different systems. There's wire-face systems. And there's also natural methods, which is kind of an emerging design methodology, but the idea of using root wads and trees in stream banks and stuff like that. But that's kind of what we typically see. So you think about these projects that we just looked at. What is normally done to solve those problems? Maybe you throw rock at it. Maybe you throw some concrete at it. You know, come up with a variations for like a TRM or a combination of a TRM and a geosynthetic system, or like I said, a cellular confinement system that's designed to hold soil and to hold the slope in place. Or again, gabions, traditional gabion systems. There's a whole variety of those available. There's also different wire-face systems available. And some of them are designed to be vegetated, some of them are not. Some of them do well with vegetation, and some of them not so much. But another opportunity, as well as, you know, we talk about, you've seen retaining walls, slope stabilization walls, retaining concrete systems, etc. But let's talk a little bit for a minute about sustainability. And it seems to be the kind of the buzzword these days, but what makes a solution sustainable? So if we put some common sense to thinking about that, you know, we see plenty of landfills, we see recycling emerging. We're trying to reduce our landfill waste. We're trying to reuse. To me, sustainable solution is something that doesn't add to the problem, but it takes, maybe repurposes, maybe reroutes or renews some of those that waste stream or those materials that are no longer in use, and reroutes them into a new solution. Another thing to me that when I think of sustainability, I think about, is it duplicatable? Is it something that you can repeat over and over again? Is there a source of supply? Is there a way to repurpose that? Along the lines of sustainability also is native vegetation has become a much more common tool in sustainable design, adding vegetation that is common to that area to support those slopes and those embankments, to hold that root system, to hold in place. But the bottom line in my mind is does your solution add value? Does it add value to the environment? Does it add value to the economy? I mean, think about all those workers there at that recycling center that have a job, because instead of just taking it to the landfill, they have an opportunity. They're working to repurpose that material. So there's an economic impact as well as an environmental impact. We're seeing in the media, in publications, different trade publications, articles, about vegetation, about green infrastructure. For example, living green walls lined with trees and bushes could help reduce toxic pollution. Just this year, that was last month. So you're starting to see more and more talk and discussion and movement towards that design methodology. Sustainable residential design. Plants are central to a functioning global ecosystem. Plants oxygenate the atmosphere and reduce atmospheric pollutants. So utilizing vegetation and natural vegetation in the environment is kind of an emerging design practice, which I'm sure is why most of you are involved with this webinar today, because you're looking for those kind of solutions and opportunities to add to your toolbox. So, I mean, even around the world, sustainability through vegetation. This was back in 2016. The Asian green building mindset. This is a mindset that's permeating all over the world, not just in the country here in the U.S. So how does Filtrexx fit into this? What is our story? Who are we, and what do we even have to say? What do we bring to the table? Well, we're one part compost, we're one part mesh, and one part ingenuity. And you put that together, and as a recipe, it gives you a simple recipe of recycled organics, and coming into the industry with performance and environmental sustainability around the globe. So if you look at this picture here, kind of in a nutshell, what we're all about is the bottom left picture is a composted media. That's a filtering compost media. In the middle, you have more composted media that's for growing. You can plant and grow things in that. And then on the right, we take mesh and we contain those media in the mesh. It could be a 5-inch diameter sock mesh sock. It could be an 8-inch, 12-inch, up to 36-inch mesh. That's kind of what we do and who we are. We started out back in 2002 with the idea of how can we reuse organics, mesh, media, get a patent. How does that work? How do we fill that? Then we added some science with research, testing, and engineering. Started working on federal and state approvals, spec development, over 25 applications, design manuals, and then marketing. And then, which has brought us to who we are today. Kind of the creation of the Filtrexx Big Mac. You get a Big Mac in Pennsylvania is the same Big Mac you're going to get in California. And so making sure that process works. So that's kind of who we are and how we got to where we are. We deal in the construction industry, we deal in the post-construction industry, we deal in stormwater, and it's all wrapped around and tied into sustainability. So we deal with silt socks, sediment control, green infrastructure, which is kind of an erosion control application with our GreenLoxx, which is what we're going to highlight today. Stormwater applications, which is our EnviroSock, which is a removal of pollutants and for environmental, non-point pollution sources. And then you wrap it all up in this concept of eco-practices. So it's a high-performant SMP instead of a BMP. We're talking about sustainable management practices for all phases of development. So that's kind of who we are. How do we get that to the market? What's our process? Well, we start with wood, fiber, and leaf waste, composted into certified media, put it into a mesh, for compost growing socks, and you end up with superior results in filtration and growing applications, there on the far right. But for the purpose of our discussion today, we're going to be talking about growing media, composted growing media contained in a mesh sock, like you see on the right there, and utilized in bank and slope restoration projects. That's what we call our grow sock. Those are actually an 8-inch diameter sock. They're 3 foot in length for the application that they were designed for. So that brings us to Filtrexx and our Filtrexx solutions for bank and slope erosion. Let's take a look at how that grow media works in our application. Our GreenLoxx system, which is kind of our green infrastructure erosion sediment control, it can be applied into 2 different ways. There's an MSE version and there's a non-MSE version. And I won't assume that everybody knows what MSE stands for. MSE means mechanically stabilized mechanically stabilized earth. In other words, it's reinforced with some kind of reinforcement. The non-MSE system does not have a mechanically stabilized reinforcement. So as we look at these two, an MSE wall can go up to 80 degrees. A non-MSE can be up to 50. Keep in mind, you're going to see a project or 2 that are above that. So there's always exceptions to the rule. The difference between an MSE and a non-MSE is the slope stability. MSE has instability issues. Geotechnical reports determine slope failure and plane and grade and all that. Whereas a non-MSE system is going to go on a stable slope. So it may be eroded. It may not be holding vegetation, but the slope is not slumping and the whole thing isn't falling out. MSE uses reinforcement like any retaining wall application. Non-MSE uses a wrap sock, still uses a geogrid, but it wraps and anchors the sock with a soil anchor system. In an MSE wall, just like any retaining wall, you have ability to have a setback. That's kind of the angle of the face. They also call it batter. And it's typical retaining wall design, and it's engineered for the application with the soils data and the soils information. With the non-MSE, there is a methodology. We use a soil anchoring system depending on the type of soil. From a soils report, depending on the type of soil that we have, determines where the anchors go, how far apart they go, how deep they go. But in non-MSE, a non-MSE GreenLoxx application is an anchored vegetative facing, as opposed to a MSE, which is a retaining wall with a vegetative facing. But it's anchored by the reinforcement behind it. And then, of course, you seed that. So hopefully that makes sense of the two, an MSE versus a non-MSE, and we're going to take a look at these. This is what an MSE looks like. There's no difference from this than a block retaining wall that you might see in this kind of application. The difference here is that we put our grow sock, our sock in the face of that wall, and it has organic material to grow out and vegetate the face of that wall. So let's look at the MSE. It's a GreenLoxx MSE reinforced living wall detail. If you look here, there's no real difference in this wall than any other MSE or retaining wall system, block retaining wall, with the exception that these in the face are grow sock, and they hold an organic media designed to support strong vegetation. So, but you still have compacted backfill behind the system. You still have layers of reinforcement, and your height and your depth is determined based on the stability or instability of that slope, and how far back you have to go to cross the plane of failure, as well as to be able to reinforce that. There's drainage, just like a typical retaining wall. So this kind of just gives you a good overview of the CAD design. And we have these available with design guides and CAD drawings for our system. But let's take a look at a couple installations just so you can see the process by how we start with a slope or a bank and how we turn that into, you know, it gets cleaned out and then you build up layers. You can see here, you know, they're putting the backfill in as they go up. You can see 2 layers of sock. Now this kind of sock was actually what we call blown in. It doesn't come in a pallet. It uses the blower. They used a blower truck for this application, and they blew the sock in, and then they put the sock. They put the backfill. They wrap the geotextile. You can see down here at the bottom how the geotextile is wrapped around it. It's a geogrid and holds that system in place. Up here you can see these are extra layers of grid that are waiting to be wrapped back, and they're pretty long because of the height of the wall. There's an embedment that reinforcement has to cover. Here's another good picture of that. You can see the wraps of the geogrid on the face. Very nice looking wall as they're building that up. And here's a final to that. So it's that process of laying your grid, laying your sock, putting your backfill, wrapping your fabric, and just working your way up as you repeat that. Let's look at one that was used, installed with our grow sock material that comes on a pallet as opposed to is blown in on site. The nice thing about it in this application and this way is that it shows up to your site on pallets. The grow sock that you see here, these grow sock were probably made within a day of being delivered to the job site, so they're new. They haven't been sitting on a shelf, and they're about 30-40 pounds each. They're soft. They're easy to maneuver. You can see the backfill here. You can see the geogrid. Notice something about this geogrid that's different from those of you that have seen geogrid or worked with geogrid in the past. The difference here is that these openings are bigger. They're actually a 2x2 geogrid. It's specially made for our system and designed for our system. And the intention there is it still has long-term design strength, still has pull-out strength, it still has engineering numbers that work for your design. The difference is because that opening is bigger, when you wrap that face and you build that wall, as they're planted, the sock are planted with just a ground cover. But if you wanted to plant live stakes in there, willow stakes, if you wanted to plant native plugs in there, instead of going in and cutting the grid, you're going to you have room on a 2x2 opening to make a little cut in the sock and plant a seed without having to cut the geogrid. The geogrid reinforces the face and the slope and the embankment. You don't want to damage that. So that's what's important to why it's important to have a 2x2 grid. And then it kind of grows out like that. So let's look at a Streambank project profile. Again, these are common all around the country. You can see this looks like there's a bike trail that's being eroded into. The Streambank needs some restoration. This is actually looking from here back up to the project again, because there's the trail again on that side. As they build up the wall, the face, you can see the drainage in the middle. You can see the compacted fill behind it. They basically just replaced that section with a reinforced area, and that's how it grew out. Very beautiful, very sustainable, adds vegetation, adds biodiversity and habitat. So that's the MSE system. Let's take a look now at the non-MSE system, and because it's a little bit different. So let's just see what the CAD drawing looks like on that. So here you have, sometimes I kind of liken it to a mattress that's attached to the face of a slope, and you've got your sock. You can see your sock, and they're wrapped in the geogrid. Let's get a closer look at that. So you've got your geogrid, which goes all the way down along the bottom, comes up, and it wraps around each layer of sock. And here you see an anchoring system. There's soil anchors that are pounded into the ground. Now you see there's 2 sock. Sometimes there's 3, but most often it's 2. Sometimes these are 8-inch diameter. Sometimes they're 12. It depends on the slope. Depends on some of the geotechnical information there. And so you'll notice that we use a soil anchor, 3-foot minimum depth, or other anchor strength as per the engineer. So let's take a look at that, the components. All right. So you can see our geogrid here. Now this is our old geogrid. We don't use this anymore, but you can see here the head of the anchoring system is what holds that in place. And so it's driven down in, and as it's driven in, you can see that it's driven in straight down, and then as that cable is pulled up, this head turns and holds the soil anchor in place. And then this plate, like right here, this plate slides down kind of like a zip tie and anchors that system down. And so depending on soil type and depth, you have some different options for the size of the head and the grid. So that's kind of the components of a non-MSE GreenLoxx system. It's pretty straightforward, and as we go along, you'll see how flexible it is. But let's take a look at a non-MSE situation. So in this application, the slope is eroded. The slope is not holding vegetation. It's erosive forces is washing the face of it away. And this one's kind of jumps quick, but it shows you with the system attached and the vegetation taking place. And you can see here they put some live willow stakes in here that will take over and end up growing out to look like this. So that's kind of a quick step process. Let's take another one that's a little bit more in depth. You know, stream banks that are eroded, severely eroded. You can see the roots exposed. You can see they're going to lose this fence. You know, there's some high flows. This is down in South Carolina. So, you know, sometimes they get some heavy rains at times. And here's another angle of the, you know, erosion that's taking place. This is a culvert, so the water would be flowing down into the culvert. So to come in and clean up and get it ready, you know, and to apply the GreenLoxx system, this is the non-MSE again, you can see how flexible it is. It's basically like lining the channel with an organic material. Now, there's other systems you could do. Historically, they might put rock along this. Sometimes they might use a TRM, you know, but at that point, you're not adding any organic material to the face. And your chances of success with vegetation taking over are less because, you know, quite often site soils are not, do not have enough organic material in them to support vegetation. The other thing to notice about this application is as you look down here, I mean, they went right around this tree. They didn't have to take that tree out. Now, there might have been some small shrubs and bushes that were taken out just to clean it up and make it workable. But, I mean, you can work around. It's a very flexible system. And then as it grows out, that's what you end up with. Again, because you're adding to it a very strong organic material to support that vegetation. And if you notice here, this actually, you can tell this grass is matted. This just at this taking this picture just survived a pretty heavy duty rainstorm. I forget one of those multiple 100-year storms, and you know, people would say, well, what's the damage to that? And does it move? Does it shift them around? Does it move them? When you anchor these, and you notice that these wraps are pretty tight, they're holding it in place. You're going to see very minimal. I think they had to go back on here and spend a couple $100 just to reshift or to fix a couple areas that was very minor. I don't know if that was a 100-year storm or if it was a tornado, but you can see that it's held up very well. So that kind of gives you an overview of the two systems. Let's go a little bit deeper into some project profiles around the country. They'll talk more specifically about them. Going back to this picture that you've seen, this is in Pennsylvania, central PA near Harrisburg. Again, you can see the road is in jeopardy. You can see that they're going to have to do something. This was taken back in 2015 when this was done. And so, you know, they cleaned out, they had to shut down the road, obviously, they had to dig back a little bit. And again, normally what they might do is put riprap here, or they might do a concrete facing, but instead they wanted to go with a more sustainable, more, you know, fit with the land look, aesthetic look. So anyway, they're doing the wrap. You can see the geogrids coming back. You can see they're putting in the compacted fill behind it. And they're wrapping them up. Nice rows of sock wrapped, nice and uniform. Not that it matters per se, because it's going to grow out like that. And the nice thing about a living wall or a living structure is that once the vegetation takes over, you really don't see what's behind it. You just know that it's, you know, supporting it and holding it up. And put a little bit of rock down at the bottom to support that, and it's a very nice result in Pennsylvania. And this was, I don't know if this was a county highway or a Pennsylvania DOT, but, you know, the nice thing about it, again, is, you know, if you think about it, they saved that road, and when you get heavy rains, and you're still going to get flow in here, but the system can hold that. We've done some studies that, you know, up to 12 pound shear stress or more, you know, that the GreenLoxx system can manage. But also, if you think about what's coming across the top, if a heavy rain is coming, you're getting sheet flow this way off the face of that. Well, first of all, you've got an open graded and a backfill behind there that is help absorb the overrun. But the other thing you're going to have is, you know, open organic media, composted media in the face of that, that's going to also help absorb sheet flow and erosion runoff. So because the grid's there holding that and the vegetation's there holding it in place, it's kind of like a double whammy to support the face of that wall. As opposed to if you put riprap there, that would slow it down. Or if you put a retaining wall, that it's not going to absorb anything. It's just going to throw it all into the stream. So there's a little bit of benefit there. Let's look at a project down in Springfield, Missouri. I think this was done back in 2010. You can see they've got, this is a subdivision over here on the right, and there's the edge. They're making backyards for people for their houses, and so they wanted to put some kind of a wall system in there to offset the difference, you know, the difference between the properties. So here you've got some geogrid being laid. They're laying out the footwork there, the foundation. They've already started to compact the fill on the first layer. This is sock that was continuous through a blower machine. And then as they go, again, you can see the nicely wrapped geotextile wrap face. If you've ever seen wrap faced walls, the difference with ours is that we use a geogrid instead of a geotextile. And so you've got some nice lines along there. It doesn't have to be perfectly straight, but there is some consistency there. And you notice there's a pretty reasonable setback. They're able to control the angle. And so that's what it looks like finished. And then it grows out to look like that. And so, you know, a homeowner in the back, instead of having a concrete wall, you know, can have some vegetation and some habitat that offsets them from the woods there. So let's take a look at a project down in, this is on the Alabama side of the Chattahoochee River, down, Georgia. I think it's Phoenix, Alabama, or Columbus, Georgia. You can see here, there's a transmission line that runs through. What you can't see just to the right here is that there's a tower. This face is eroding, and they wanted to make sure they weren't going to lose their tower. So here's it from the other end. You can see a better idea of what's up there. You know, this is a good, you know, 20, 30 feet, and then you've got a 40-foot, 50-foot tower above it. So they excavate out the face. This was an interesting project. They were originally going to do a non-MSE system, which I just got done showing you. But as they got into soil reports and understanding the depth of the pylon and the reinforcement that could be required there, they moved to a MSE, a reinforced face. So what's interesting is they went to work. You see this the Chattahoochee River here. This is a dam-controlled river, and and there's all kinds of great recreational opportunities on there. But this water level goes up and down based on whether or not they open a floodgate or two, or not a floodgate, but a control valve for running the generators. So when they started this job, when they went out there, this was actually underwater, and this is the power company's transmission line, and the same power company runs the dam, and so they had to talk to each other and say, hey, we need to be able to build this and replace this. What are your release hours? Well, this was done back a year or two ago, and the weather had dropped 10 or 20 degrees, and everybody turned on their furnaces for the heat. It was in December, I guess, and they needed more power, so they had to work with themselves, with their other parts of their company, to make sure that they could do this project and not be underwater the whole time. So what that required was they had to actually do it at night, or at least get the first part of it done between dam releases, and while the water was down. And so here they are, they're rolling out the geogrid. They've placed the sock, and they'll place the sock on top of this, and then they'll wrap it. And then you can see here they've wrapped it up. This is really cool. We did a lunch and learn here the day of that with some local engineers and the owners, and it's really interesting to be standing on a project at the bottom 20 feet and looking up at a 40, 50-foot tower. But it was a really good opportunity to show people on hand, on site, what this project looked like. As they built up, one row after another, get to the top, you can see the tower a little bit better, and the grass grows out, and it vegetates, and a great solution for this situation, instead of putting a rock face or another system that may not be as good at holding vegetation in place. Moving to Wisconsin, this is a residence overlooking Lake Michigan. Wanted a better face to their backyard so that it would look nice, and that they wouldn't continue to lose their slope. So they put in a GreenLoxx. This is a combination, I think, GreenLoxx MSE and non-MSE. So you can see they're laying that. They've got it built up on the left there. They've added the steps. You can see it from the other angle as it's starting to grow out. And then this is what it looked like in the end, which is just a great example of taking something that's highly eroded and giving it an alternative solution. Here's a project in St. Louis, Missouri. Homeowner wanted to do some nice landscaping in their backyard. You can see there's a rock water feature that's going to take place right there, and it turned into something like this. So what's cool about this is that if you're a contractor that does residential contracting, this gives you a very soft, very flexible system to utilize with very unique and different flexible situations. Here's a project out in California. What you can't see under here, you saw this picture before, but this is protecting a stream, some highly regulated areas out in California, and I think there was a steelhead stream out there. So they needed to repair this slope. Again, you could see that they had tried to put a wall up. They had plastic to try to keep the surface from eroding, but because there were some regulations, they had to cover and protect that stream. And so this is kind of what it looked like as they were installing it. Now this is a non-MSE. You can see they've rolled the geogrid down the hill. They've set the first layer of sock, 2 layers of sock. Now, if you remember back, I said that a non-MSE system is about a 50-degree angle. This is way more than a 50-degree angle. So just keep in mind that there's always an exception to the rule. Again, you can see they had to come up with a pretty extensive way to protect that stream, but to be able to work on the stream bank, on the slope as well. So as they start to move up the wall, you can see they're buttressing up, they're laying up the sock as they go, and it is a relatively steep wall. Just to give you some perspective on how steep it is, this is our rep out in Northern California that was on site for this project. And I guess I should say also that, Filtrexx is nationwide. We've got reps all around the country. So if you have a project, we can support your needs, on site, as well as, project design. But then, you know, then you got to plant it, and you can see they're putting some plantings in there so that it'll grow out. And there's the face of the wall. And it's really it's more like a slope. You can kind of see it over here, these little blue things sticking out. That's irrigation to support and help it get established. Again, great soft system, didn't have to cut down the tree. You can leave it in there. It worked with the system, it's very flexible. And as it grows out, gives you a very natural look. And as most of you know, or some of you may know, California just came out of a drought for the past couple years. And this is looking pretty good. Last time I saw it, it didn't look this great, but it wasn't super exposed. You couldn't just see the sock. So, you know, the right kind of species of plant, the natural vegetation, I think there was over 60 different species of natives that were planted in this wall. So anyway, a very nice system, a very, very nice looking result. So let's talk about some of the benefits of these systems. You know, a sustainable BMP and what's the impact of them. Well, because we're using organic material, that growing media, we're redirecting organics. So all the organics that are in our systems, instead of going to a landfill, they're going into the grow sock, which are going into the face of a wall. So that's a really strong thing. Then there's a carbon impact. Because we're using organics, because we're using vegetation, it significantly reduces the carbon footprint. Methane avoidance, you have methane avoidance from the diversion of the organic from a landfill. In other words, if that organic ended up in a landfill, it's going to be releasing methane in the landfill as opposed to, you know, housing and supporting vegetation on a slope. You know, carbon sequestration in the soil as well as in the vegetation. In other words, it's capturing carbon in the soil and the vegetation as opposed to just sitting in a landfill. So there's some real benefits there. Of course, anytime you vegetate anything, there's a benefit because you're holding soil in place and you're helping to keep that soil from being dislodged. Some other quick impacts, you know, heat island. If this was, you know, this little picture here, if this was a retaining wall, even though it's in the shade, it's going to absorb heat and it's going to release heat throughout the day. You know, and that's really the big issue in my mind. One of the big issues with concrete block walls is that they absorb heat and they release heat, and that heat island effect is real, as well as the whole sustainability of concrete, but that's not what we're here to talk about. So you got biodiversity in the habitat, you've got native pollinators, you've got filtering of the air, so you've got air quality, and you've got stormwater runoff absorption. So let's talk a little, you know, we'll talk about that here in a second, but you know, the role of vegetation in sustainability is becoming more and more common, and this is just something I saw where, you know, there's quite a bit of publications coming out, you know, but look at this, where it says many aspects of the performance of infrastructure slopes are affected by vegetation. And so, but many are conventionally overlooked by engineers. So vegetation in your slope restoration projects is a key to sustainability and success. So let's look at this a little bit closer. This is that same picture that was in that other wall or other slide. This is a project up in Saratoga Springs, New York. So let's talk about stormwater absorption. Because you're using composted organic material, there is a certain amount of, because it's got high organic content, about 50%, high porosity, high relative surface area, compost has the ability to absorb significant amounts of water. So in this particular wall, it's only 3 or 4 feet high, but as you look at this, it's got a vegetated face as opposed to a concrete face. And the picture on the right shows a parking lot. Well, that's a porous parking lot, intentionally designed for water infiltration and absorption. Well, all that water absorbs and percolates down into the base of the parking lot, but also it's going to percolate and be caught in the face of that wall, which is going to help support the vegetation in the face of that wall, and it looks vibrant. And in essence, if you think about it, what you're doing is treating stormwater in that parking lot. Very little, if any, of that stormwater is going to leave the site and have to be managed elsewhere. It's being managed right there. So if you think about these retail development centers where they're putting in these huge underground detention basins because they need to collect the water. 9 times out of 10, those situations require some kind of slope or grade change, and you need to put a retaining wall of some sort. Well, in that case, why not put a living wall system in place of a block retaining wall system and tie the systems together to treat that water on site to support the vegetation in that face? It just kind of makes sense. So there's some opportunities and benefits there that, when was the last time anybody you talked to said, hey, I'm designing this retaining wall because I need a BMP? It doesn't work like that. People don't think that way. But you can with a living structure system like our GreenLoxx system. So let's talk about sustainability by the numbers. What's the impact? We have a eco service benefits tech link, which is available on our website for downloading. But let's just take a closer look at the numbers and some of the things I just got done talking about. So you're talking about recycled organics, waste diverting these materials from landfills. Let's see. Amount of organics recycled diverted from landfills per linear foot of 12-inch sock is 80 pounds. So then, and then in the gross sock, a linear foot of 12-inch gross sock is 160 pounds. So all of a sudden, these numbers are going to add up, and you'll see in a minute. Water absorption. A 12-inch diameter sock, which equals 1 square foot of living wall growing media, can absorb up to 4 gallons of water. All right. You look at carbon footprint, and this is all information that's in that tech link. I just wanted to bring it out so that you could see a little closer. So in this tech link, you've got carbon footprint reduction, methane avoidance, carbon sequestration in the vegetation and in the carbon. So I would, if you're interested in this kind of stuff, I would download this and take a closer look at it. But then you start to do some you can do some calculations with this reference guide, which is in the tech link again. The water absorption, an 8-inch gross sock, 1.7 gallons per foot, 12-inch, 4 gallons per foot. So you can start to look at here and see how many organics are diverted. 12-inch sock, 80 pounds. All right. So there's a reference guide here, and this isn't something that we just pulled out. Here, let's go back here. You'll see down here at the bottom we have references of where those came from: California Environmental Protection Agency, Chicago Climate Exchange, and other publications that are out there, US EPA. So these numbers are numbers that are validated and verified. So let's take a look at these projects again. So this is that project out in Gilroy, California. This is the dimensions of the wall. And let's just real quickly, we're kind of coming close to the end here. So let's quickly, organics diverted from landfills, over 500,000 pounds. Potential rainfall absorption, 14,000 gallons per event. Methane avoidance, over 1 million pounds of carbon dioxide. Carbon sequestration, carbon in the soil and in the vegetation. So all of a sudden, this wall that was just there to support the, to solve a solution has a verifiable impact. Same thing with the roadway in Pennsylvania. Over 500,000 pounds of organics that would have gone to a landfill, over 13,000 gallons of water can be absorbed per event, and the methane and all the other numbers you can see there. And you can see there's a real calculated impact, so that you can go back to your constituent and say, look, here's how we are being environmentally sustainable with what we're doing. Project in Wisconsin, over 300,000 pounds. Over 8,000 gallons of water. You're the homeowner, and you all you really wanted was something beautiful and a way to hold your slope in place and your backyard to look nice. But you got an environmental impact that you had no idea because of the solution that you chose. Same thing in South Carolina. This one's big. This is over almost 3 million pounds of organics. Over 72,000 gallons of water can be absorbed. The numbers start to stack up pretty quick. So coming close to the end here, there's all kinds of resources out there. The Sustainable Site Design Manual for Green Infrastructure is a great tool for low impact design. ECOPRACTICES. Now this is something new and unique. This is an organization that is recognizing responsibility. It's a third-party verification partner for Filtrexx and other companies to verify these sustainable practices that are being done. you know, based on the management of organics for maximum verifiable, documentable environmental service benefits. And so, you know, this is an opportunity for organizations to say, hey, I want to be more sustainable. How can I do that? How can I validate that what is being done on a project is truly having an impact? This is how you do it. So let's, coming close to the end here, let's look at Filtrexx by the numbers. You know, we're a company with a mission. And as we look back in this concept of sustainability over the past year, 2017, our impact as a company based on what we've sold and what we've done, it's kind of a great testament to what we're trying to do as a company. You know, almost 731 tons of organic waste that was diverted from the landfill. You know, 105,000 tons of sediment prevented from the roadways. You know, 1.6 million tons of carbon prevented from the atmosphere. Cars removed from the roadway. So it's a calculated impact that we're having by using and repurposing and changing the way you look at how you do slope and bank stabilization restoration projects. So with that, if there's any questions, if you want to type them in, thank you for your time. I hope that this was informative. So here we go.
Great. Thanks, Andy. Like Andy mentioned, we have a couple minutes here for questions. You can type those into your dashboard. One question that came through from Matt, he asks, for a non-MSE wall, what is a ballpark number for cost per square foot?
Well, that's a good question. We are happy to support and help design those projects. Typically, a GreenLoxx non-MSE is going to, a material package is going to be somewhere between $12 to $15 a square foot, depending on the constraints of the job, the engineering constraints, the size, the distance, you know, where it's at. Although I should say, I kind of didn't mention this in the presentation. You know, the organics that we're using are locally, regionally supplied. So we're not necessarily shipping California organic. You know, we're not shipping organics into California from Tennessee. We're shipping them in from California. But to answer your question, you're talking somewhere around $12 to $15 a square foot. And if you have a specific project, we'd be more than happy to kind of give you an estimate on what that looks like.
Okay. Okay, we do not have any other questions lined up here. Real quick, as a reminder, before we wrap up here, I will be sending out certificates of attendance to everyone who logged on today, and we'll also be including Andy's contact information, so you will have that handy if you have any questions that come later or want to talk about any upcoming projects. Andy, do you have anything else to add?
Once again, thank you for attending, and I hope this was helpful. And if you have, you know, we're more than happy to help you with any projects, even if it's just to kind of give you a ballpark idea of what you can do. You know, most of our reps out around the country are familiar and aware of the system and are capable of supporting anything that you have from a project standpoint. So thank you.
Great. Thanks, everyone. Have a great week.